Hello, so today we are going to do this problem, unique Morse code words, which is part of Leetcode August daily challenge. So the problem says that we have Morse code that is defined with this encoding. Basically, A is this, B is encoded as this, and C, and D also like as, so this is A, this is B, C, and this is D. So we are given all the letters, the encoding of all the letters in increasing order, right? So this is for all the alphabet in lowercase, and yeah, A here and then B. So A is 0, B is 1, C is 2, and you get the idea, right? And what we get is an array of words, and we want to transform each word into its code in its Morse code. So basically transform each letter into one encoding in this list and concatenate, that way we get the code of the word. And the goal is to return the number of different transformations. So you can see here, since we have just underscore and that, some words, either because they have the same character or because the encoding concatenation ends up being the same, we get the same transformation. So the goal here is to return the number of unique transformation, right? So for example, if you take a look at this list of words and we apply the code here, for Jin we will get this one, for Zen we will get this one, and you can see Jin and Zen have actually the same code. Similar thing with Gig and MSG, they have the same code, even though different letters, right? So since here we have only two different codes, we need to return two. So that's the idea. This is a pretty straightforward problem, right? We just need to have the mapping and then go through the words, go through each character for each word, convert it to the Morse code, add it to a set, right, so that we can obtain the unique codes, and then return the length of the set. So yeah, very straightforward solution. Let's try it out. Oh, sorry. So let's write it out here. We need the code, so I'll just copy those. And then we need to have a set, so I'll call it T for transformation, a set of that will contain the code, and then we need to go through every word, and then we need to create the code for that word. So we go through every character, and then we concatenate the code for that character, and to get the code we just need the index so that we can obtain it from here. And to get the index, let's actually show in Python here. So what we can do to get the index here is to use this ord function. So for example, for A it would return 0, for B it would return 1, for C it will return 2. So it will return you the index in the order in the alphabet for that letter, and that's exactly what we want here to get the code. And so let's do that here. So the index would be, let's actually just write it down here more clearly. So the index would be the ord for the letter minus this, so that way we get the index, and then from the index we get the code. And then at the end, once we get the code for the word after this for loop, we can add it, add code. Then at the end we just want to know how many unique ones, and that's just the length of the set. Yeah, so that's pretty much it. Now we can actually move this here, that was just to make it super clear for you. Let's run it, submit. Okay, so that passes test cases. Now just for the sake of like showing a different way, if you like didn't recall this or didn't know about it, what you can do instead is just have a map of letters to their indices in the alphabet, right? And to do that, well, you could just have the key be the letter, let's call it letter, and the index be the index, and just to get those two, go through all the lowercase alphabet. And in Python, you don't need to copy them over. You can just use ASCII lowercase like this. And now instead of doing this, to get the word index, we just pass the letter to the map, right? Let's run this. That should pass. Okay, so that passes as well. Now, in terms of time complexity, we are doing one pass on the words and then doing all the character for each word. So if we just go by the words, it should be O of W. And if you want to calculate the length of the words, then maybe it's for each word, it's like the max length of word. This is like the upper bound here, and this is time. In terms of space, in the previous solution, we used this O of constant space here for the code, but we used also O of W for the set. And here in this solution, we are also using an additional O of W for storing the letters map. Nah, actually, this is just constant because it's the 26. So we only need to count the set here. The others are constant space, and the set is at most the number of words. So we have O of W space as well. Yeah, so I think that's pretty much it for this problem. It's an easy problem today. Thanks for watching. Please like and subscribe, and see you on the next one. Bye.